To set up a common base transistor circuit and to study its input and output characteristics and to calculate its current gain. A transistor is a three-terminal device formed by sandwiching a thin layer of one type of semiconductor between two thick layers of other type of semiconductor. A transistor works as switched off for its cut-off region and works as switched on for its saturation region.
Madam, how can we set up a common base transistor circuit and to study its input and output characteristics and to calculate its current gain?
In common base configuration, the base is common to both the input and output circuit. The emitter base input circuit is forward biased by battery B1 and collector base output circuit is reverse biased by battery B2. If I, E, IB and IC are emitter current, base current and collector current respectively, then IC is equal to IB plus IC. Input resistance Rin is equal to delta VEB divided by delta IC VCB is equal to constant. Output resistance Rout is equal to delta VCB divided by delta IC IE is equal to constant. Resistance gain is equal to output resistance by input resistance is equal to Rout by Rin. Current gain alpha is equal to delta IC divided by delta IE VCE is equal to constant. Voltage gain AV is equal to output voltage by input voltage is equal to Rout into delta IC by Rin into delta IE is equal to resistance gain into current gain. Let's do an experiment to set up a common base transistor circuit and to study its input and output characteristics and to calculate its current gain. Our aim here is to set up a common base transistor circuit and to study its input and output characteristics and to calculate its current gain. Apparatus required are a PNP transistor, 2 milliammeters, 2 batteries, 2 rheostats, 1 voltmeter 0 to 3 volt, 1 voltmeter 0 to 30 volt, 2 one-way keys, connecting wires. Procedure: draw a neat and clear circuit diagram. Arrange all apparatus on the table according to the circuit diagram. Remove insulation from the ends of the connecting wires using a sandpaper. Make neat and tight connections according to the circuit diagram. Keep both the potential dividers arrangement to minimum voltage and then insert plugs in both the one-way keys. Input characteristic: keep the collector base voltage VCB fixed at some suitable value, say V. Initially, adjust the rheostat R1 to give small emitter current and then by adjusting rheostat R1 increase IE in suitable steps and record corresponding emitter base voltage VEB. Repeat steps 6 and 7 for other values of collector base voltage VCB at -4 volt, -8 volt and record IE and VE. Output characteristic: keep the emitter current IE fixed at a suitable value, say 10 milliampere. Initially, set the collector base voltage VCB to 0 volt and record corresponding collector current IC. Now increase collector base voltage in steps and record corresponding collector current, keeping emitter current IE constant. Repeat steps 10 to 11 for other fixed emitter currents at 15 milliampere, 20 milliampere, etc. Transfer characteristic. Keep the collector base voltage VCB fixed at a suitable value, say -4 volt. Initially, adjust the rheostat R1 to give small emitter current IE and record its corresponding collector current IC. Now, increase emitter current in steps and record corresponding collector current. Observations. Least count of voltmeter in input circuit. V1 is equal to X volt. Zero correction for this voltmeter is equal to X volt. Least count of voltmeter in output circuit. V2 is equal to X volt. Zero correction for this voltmeter is equal to X volt. Least count of ammeter in input circuit. A1 is equal to X milliampere. Zero correction for this ammeter is equal to X milliampere. Least count of ammeter in input circuit. A2 is equal to X milliampere. Zero correction for this ammeter is equal to X milliampere. Table for input. VEB minus IE characteristic. Emitter base voltage VEB in volt. Observed, corrected. Emitter current IE in milliampere. VCB is equal to -4 volt. Observed, corrected. VCB is equal to -2 volt. Observed, corrected. Table for output VCB minus IC characteristic. Collector base voltage VCB in volt. Observed, corrected. Collector current IC in milliampere. IE is equal to 10 milliampere. Observed, corrected. IE is equal to 20 milliampere. Observed, corrected. Constant value of collector base voltage VCB is equal to -4 volt. Table for transfer IE minus IC. Characteristic. Emitter current IE in milliampere. Observed, corrected. Collector current IC in milliampere. Observed, corrected. Result. The graph between input voltage, that is emitter base voltage VEB, and input current, that is emitter current IE, shows the input characteristics of the given PNP transistor. The graph between output voltage, that is collector base voltage VCB, and output current, that is collector current IC, shows the output characteristics of the given PNP transistor. Input resistance Rin is equal to X ohm. Output resistance Rout is equal to X ohm. Current gain alpha is equal to X ohm. Voltage gain AV is equal to X. Precautions. All the connections should be neat and tight. The plug should be inserted in keys only when observation is being taken to avoid heating of the transistor. Biasing. The transistor should be done correctly, that is, input of transistor should be forward biased and the output should be reversed biased. Voltmeter and ammeter should be used of proper range. Sources of error. All the connections may not be tight. Biasing of the transistor may not be done correctly. The transistor may be faulty.
Thank you, ma'am, for this knowledgeable experiment.